Hi, everybody. So this week we are looking at slope and what slope means. So slope is the measure of the steepness of a line. It's the ratio of the vertical distance to the horizontal distance of a slope triangle. And it does matter that we're comparing vertical to horizontal each time. So we're always looking up and down before we're looking left and right. There's a few different ways to describe slope. So it's often referred to as M. It's often referred to as the change in y divided by the change in x. And this is also known as rise over run. And if you've encountered slope before, you may have heard of the phrase rise over run. It's a little bit easier to remember, probably. Change in y can also be expressed with delta y, like we saw in the Desmos activity this week, excuse my sloppy writing here, over delta x. There's lots of ways to describe slope. Rise over run, the vertical change over the horizontal change of a line. And this is shown by this diagram here. So the change in y is this distance. The change in x is this distance. Change in y is a vertical change. Change in x is a horizontal change. And we'll do a few examples here just to make sure that this is understood. So for example, this is from a graph. If you needed to find the slope from the graph, you would draw a slope triangle. That's probably the easiest, most visual way of doing it. You can draw a slope triangle using any 2 points on that line. So sometimes they'll give them to you, sometimes you'll pick them. So we're using this point and this point. Sometimes it's easier to start at a point that goes through the y-axis, for example. And we can see that the vertical change is 2. We can count that even. And we can see that the horizontal change is 1. So that makes a slope of 2 over 1, which is just 2. That is a slope of 2. Rise over run. We would get that exact same number even if we made a larger slope triangle, which isn't easy to do on this particular example. But it wouldn't matter. Any 2 points, you would find the exact same slope. Let's do another one. So here we're also given the points. You've got 8, 6, and 2, 3. The slope is the vertical change, or the change in y, so that's 3, over the horizontal change of 6. That's 3 over 6. We would then simplify that, and we'd usually leave it as a fraction. We'd leave it as 1/2. It's not wrong to call it 0.5, but since it's a ratio, we often leave them as fractions. So if it's a fraction where the numerator is a larger number than the denominator, we would just leave it that way. You don't need to write it as a mixed number. And there's other ways to find slope from here. We could actually find the difference between the y-coordinates, so 6 minus 3, still 3, and the difference between the x-coordinates is 8 minus 2, which is 6. So we will do some further examples where we calculate, but for right now we're just focusing on the actual lines and finding the slope from that. So let's take a look at these examples. So we don't have these on a graph, but I do have them on a grid here. So let's find the slope from this line here. Well, I'm looking at these 2 points, and I'm first of all going to look at the vertical distance between them. So I'm going to look down. That's going down 2, okay. And horizontally, that is 4. So that's the slope of 2 over 4, which is also a half. Now I could have used different points, not just the points given here, and I could have used this middle one. This also would have given me 1 over 2. Still would have been a half. So with this one, it's a half. Now let's take a look at this, and you can see it's going in a different direction here. So because it's going this way, instead of increasing as you look left to right, it's decreasing. This is going to be negative. I'm going down 1. I know it's not perfectly on the line here. Down 3 and over 1. So that's going to be negative 3 over 1. So when you see the direction of this as it's decreasing, that'll be a negative 3 over 1. Let's take a look here. I should say also I could leave that as negative 3. That would be fine as well. I don't have to write over 1, but it's okay to do that. So this is negative 3. I'll just circle the best way of writing it. Now we can see from looking at this that it's positive. I have a choice. I can either go down first or I can go up. It does not matter. It really doesn't matter when you look at this. Just pick a way that works for you to be consistent. But you're going between the 2 points. And I went down for the others, so maybe I'll go up for this. I'm going up 4. So again, it's still a triangle here. So I'm going up 4 and over 1. So this is a slope of 4 over 1, and it's positive because as I'm looking left to right, I'm increasing. This is a slope of 4. I have another negative one here. And we'll get used to what these look like. We'll be able to recognize these right away. As I'm looking left to right, it is going down. So this is negative. And again, I've got a choice here. I can either go up from this point or I can go down from this point. And it doesn't matter as long as I get this ratio out of here. So this is 2 and this is 3. That's a slope of negative 2/3. So that's how you find the slope from a line, from actually a physical line that you're looking at. Like I said, there are other ways to calculate slope. You can find the difference between the y coordinates divided by the difference between the x coordinates. So again, let's just recap this idea, this visual here. This is a negative slope. As you're going down that hill, I would look at this from left to right. That's how I would visualize this. As left to right, you're going downhill. A slope of 0 is straight the way across. A positive slope is you working hard to get up that hill. There's one that's not included here, and I'm just going to put it in, and it's an undefined slope. So let me just get a solid line here. An undefined slope is this. So visualize this as one that you couldn't do anything with. It's impossible to do something with it. We call this undefined. I should have typed these, I'm sorry, but undefined. I know my videos are not the best looking ones. This is an undefined slope. So these are your 4 different scenarios for slope. These are the main points we're trying to get across this week. Let's draw a slope person with me. So if you have your note paper, anything at all, do this. I really think that this is helpful when drawing, when trying to remember what different slopes look like. So I'm going to draw a slope person. And this is a negative slope. So I'm going to, these are my eyebrows. This is my negative slope, and I've got that negative sign there. I have a positive line. I'm also color-coding mine. As you can see, my lines are going to be blue here, my slope lines. This is positive. I've got a slope of 0. Oops, I need to draw a straight line for that, don't I? I'll use the straight line here to do that. I probably should have done that for all of them. Hopefully you're doing this along with me. So here's your slope of 0. Oh, that is better. I'm going to go over all these actually. So that's positive. That's negative. This is a slope of 0. So you can put this wherever you want to, but I'm putting my 0 here. And then we have this undefined slope. I'm going to put here for my person's nose. And I'm going to put a U for undefined. That is my slope person. You can do whatever else you want to with your slope person. Give it a face. I don't know. I want to make that clear, actually, don't I? Hold on. Didn't want to fill that in. So yeah, I found in the past that a slope person can be really helpful in remembering. So, give your slope person some hair if you want to, whatever you want to with your slope person. But this is one way of remembering the different types of slopes. We've got negative, we've got positive, slope of 0, and undefined. And this is one that we did last year in class. So, this is slope person, just an easy way of remembering the different types of slope.